Good morning, ladies and gentlemen. I'd first like to start today by saying that I'd like to thank Mark and Matt and the sponsors and all the committee members that helped to make this conference possible. I know I've learned a lot so far, and it's nice to see that people from our discipline can get together and discuss the future of GIS and the direction that GIS seems to be moving. So today, I'd like to talk to you about using GIS to locate and examine the impacts of oil and gas wells on public lands. All right, so today's agenda. So basically with Dr. Tom Mueller, when he came to me and told me about this conference, he said, hey, can you present at this conference? And I said, let me think if I have any projects that I've been working on lately that I'd like to present. And these two came to mind. The first would be determining which PA public lands have the most oil and gas wells. And not only that, but ranking these public lands to determine whether they're good study sites for looking at the environmental impacts of oil and gas wells on those lands. And also my second project, locating traces of wells from the 1950s and earlier. So I'll move on to project one first. So my supervisors came to me and they said, we want to go study the impacts of Marcellus shale wells on public lands. And they said, I want you to find the top 5 lands based off of the number of wells and also the amount of production on these wells over the past 5 years. And so in my mind, I'm like, well, I'll use GIS to solve this. So my objectives as I saw them were to display the public lands which could best serve as study sites and use GIS to determine the production over the last 5 years. So I started like any good GIS analyst would start, and I started by gathering data. And what I first did was I'm like, well, I got to find out where the wells are in Pennsylvania. So this is a picture, this is not a map. A little disclaimer here. If Dr. Miller was here, he'd get real angry with me and say this is not a map. It's not a map, it's a picture. This doesn't have a map essentials, there's no north arrow on it. I got it. So, there's a legend though. Anyway, so it's got the 2 data layers that you see here, well 3 actually, but it's the Marcellus Shale Formation and also all the wells that were in Pennsylvania, the Marcellus Shale wells that were in Pennsylvania at this time. And at the time I created this project, these wells were for the first half of 2012. So there's been some changes, but this information will suffice for what I'm trying to tell you. So, here's all the wells, but which wells are on public lands? So what I did was I worked with some spatial queries and some attribute queries, and I cut it down to the wells on public lands. So as you see here, here is a layer of all the public lands in Pennsylvania and just the Marcellus shale wells that were on public lands at those times. So that's what I had to work with. Now came the job of ranking these from 1 to 5, given the number of wells on the lands. They said, hey, the ones that we want to look at are the lands that have the most wells on them. So I said, all right, I got to find out where the most wells are, and I have to rank these lands. So after using select by location on the public lands to find out which lands had the most wells, these were the 5 I came up with. They're all state forests, except for state game land 59. There goes the Army stuff, 059. Anyway, state game land 59, and also had the least wells, and Tioga State Forest had the most wells. And so I was able to use select by location to find out that these were the top 5 public lands. So the next thing I needed to do was I needed to present this information to my boss. And so I wanted to tell him, hey, these are the top 5 public lands based off number of wells. And so what I figured, hey, what is the information he needs to know? Well, he needs to know the location of the study sites. He needs to know where the wells are located, and he needs to know how to reach them. So I basically presented each of these lands to him in this format. I said, all right, here's Tioga State Forest had the most wells, and so this is how I presented it to him. I said, here's where Tioga State Forest is located within these counties. I clipped the wells so that I had exported them to another layer so you can see, hey, these are just the wells that are within this particular state forest. And I did a little picture within a picture, as you can see here, to show them, hey, these wells are spaced kind of close together. So if you zoom in more, you can see these wells are actually tightly packed. There's actually 262 wells there. It just doesn't look like it. And then from there, the final product that I gave him was a map that I downloaded from the DCNR's website. And I superimposed the wells upon this map using georeferencing. And so I said, hey, if you're looking to go to this particular state forest, you can use the road map here and find the locations of these wells. And I thought it was better than creating my own map layout, because it saved time, and it's probably more accurate because it's DCNR's map. And I figured that the georeferencing would be a better approach to that than for me to create my own map. From there, I had to look at production levels. I didn't just look at the number of wells. So there's a lot of numbers on this slide. What I'd really like you to take away from it is how I use GIS to come up with these numbers. So the wells layer had a attribute field that showed the level of production for 2012. And so what I did, I just highlighted the field and I calculated statistics, and it gave me a sum. And so instead of going through the entire table and using a calculator to total it up, I just used the calculate statistics function, and it popped up with these totals quite quickly. Another thing I'd like you to notice is you can notice Tioga State Forest isn't number 1 on here. So just because it had the most number of wells doesn't mean it has the highest production. So I wanted to keep it open-ended for my supervisors to let them know, hey, if you're looking to go explore these wells based off of production, you might want to look at a couple of ones before, like Sproul, that has more production than Tioga. But if you're looking for number of wells, you might want to go to Tioga State Forest. So I tried to keep it open-ended for them. From there, I took those values and I put them into Excel, and I created this pie chart because I felt it would apply to more visual people. I know I'm more visual, so I like to see charts. Finally, the final chart product that I gave them was this. And what this shows is this is the number of wells by type. I didn't just look at Marcellus shale wells. I looked at all oil and gas wells to include Marcellus shale wells. And so I said, hey, if you're looking to go to these particular lands and to take a look at the oil and gas wells, take a look at the blue bar. The blue bar is going to show you all oil and gas wells. So if you want to go to Sproul State Forest, it has the most oil and gas wells, but it doesn't necessarily have the most shale wells. Tioga has the most shale wells, and so I created this chart so they can differentiate between shale wells and oil and gas wells. So what I learned from this project, and hopefully you'll be able to take some things away from this. This is what I'm hoping from this presentation in general. Basic GIS functions can help you accomplish large tasks. I was surprised at the basic GIS functions that I used that allowed me to accomplish this project. It really wasn't that much. I can count it on one hand. I used select by attributes, select by location, georeferencing, calculate statistics, and then if you want to add number 5, ground truthing, that they would do when they would go check it out. So it really, sometimes adhering to the basics is a lot easier than doing complex geoprocessing. It just depends on what you're looking to accomplish with your projects. Also, augmenting an existing map may be a better option than creating a whole new one. Like I said, I use that DCNR map instead of creating my own map, and I felt like that helped to save time, and also it could be more accurate in the long run because DCNR can map their forest probably a little bit better than I can at this point. So I'll move on to project 2, and that is locating the historical well sites. So my supervisors came to me on this one, and they said, I'd like you to use GIS and satellite imagery and elevation models and see if you can find some traces of historical wells from back in the 1950s. So what I did, what I saw my objectives as, were to use these bare earth DEMs and look for traces of wells. I could create a hillshade and look for depressions in the actual landscape of the DEM, and then compare that to satellite imagery and look and see there might be some traces of wells from the 1950s. And then from there, if I did find a trace, I'd mark it with an XY location that they could go back later on. And if they wanted to explore this location, they would know where to look. So this was an old map that they gave me. And so I used the DesignJet scanner to scan it into and then import it into GIS. From there, I georeferenced it to satellite images of the area. And then I downloaded USGS DEMs to see if I could locate traces of wells. But I ran into a problem. And as you can see here, this is not the data that I used, but I figured the data that I use is with the Geosciences division. I don't really have access to it right now. However, this picture should suffice for what I'm trying to tell you. Basically, the DEMs that I downloaded, they weren't too much better than what you see in the picture on the left. And there's no way I'd be able to find traces of wells from the picture on the left. So what I decided to do from there was look at LiDAR data. And using raw LAS files and using geoprocessing, I was able to make my DEMs look kind of like what you see on the right, maybe a little bit better. And so here's how I did it. I took there's actually, as you probably know with GIS, there's a couple different ways to accomplish the same task. And the more you experiment, the more different ways you find out to accomplish that same task. So if you look at the ArcGIS help menu, what they tell you to do is to take a raw LAS file and then use the LAS to multi-point tool, which is located in the 3D Analyst toolbox. You run this tool, and it'll give you a multi-point layer in GIS. From there, you can run the multi-point to raster tool, which is also located in the 3D Analyst toolbox, and it will give you a LiDAR DEM. If you want a more detailed LiDAR DEM, in the multi-point to raster tool, there's a little drop-down box that you can click, and it'll allow you to incorporate interpolation into running that tool. And I like to use spline, so I always put spline. But if you use spline, then you probably will get a more detailed LiDAR DEM. However, it will increase the processing time. Or you can experiment a little bit like I did. If you go down the right side of this little diagram, this is the process that I used to create my LiDAR DEMs. I took the raw LAS file, and instead of using LAS to multi-point within the 3D Analyst toolbox, I used the LAS to point tool. Well, it's within the same tool. You can just choose whether you want to create a multi-point layer or a point layer. And when I created this point layer, it gave me a lot more points to work with. So when I ran the interpolation, the surface that I got from the resulting interpolation was a lot more detailed. And from there, that LiDAR DEM was sufficient enough to allow me to find little depressions in the ground, compare them to the aerial imagery, and find traces of the historical wells from 1949. So the things that I learned during this project were sometimes using LAS files to create your own LiDAR DEMs can allow you to conduct more detailed analysis as opposed to downloading the standard USGS DEMs from their website or anywhere else that you like to download DEMs. There's several ways to do this, but experimentation is key. I've found a lot of times in my experience with GIS, there's multiple ways to do one thing. And if you do experiment, you play around with the software a little bit, sometimes you'll be able to find better and better ways to do the same thing. Here's my concluding points reiterated from both projects. I hope that you were able to take something away from this. I know that every time I work with GIS, I learn something new. And if you didn't learn anything new from this, well, I hope you enjoyed my little story about all the trials and tribulations I went through. So that's about it.